differentiation of exponential functions. Suppose we want to find the derivative of x to the power x. How can we do that? Well, it's certainly not equal to x times x to the power x minus 1. The power rule can only be applied to functions of the form x to the power a, where a is a constant. It is also not equal to x to the power x times ln x. This only works for functions of the form a to the power x, where a is a positive constant. So what can we do? What else? Well, we can use the formula that x to the power x equals e to the power ln of x to the power x. And that's equal to e to the power x times ln x. Indeed, now we find that the derivative of x to the power x equals the derivative of e to the power x ln x, and that's of course e to the power x ln x times the derivative of x to the power ln x, using the chain rule. This derivative of x to the power ln x can be computed using the product rule. It's the derivative of x, which is 1 times ln x, plus x times the derivative of ln x, which is 1 over x. So we can conclude that the derivative of x to the power x equals x to the power x times ln x plus 1. This trick can also be applied to many other functions of the form fx to the power gx. Indeed, fx to the power gx can be rewritten as e to the power ln of fx to the power gx, and that's then e to the power gx times the ln of fx. And now, of the latter function, we can compute the derivative using the ordinary rules about differentiation. So, the derivative of fx to the power gx equals the derivative of e to the power gx ln of fx, and that's e to the power gx of ln of fx times, that's the chain rule, the derivative of gx times the ln of fx. Now this is then of course fx to the power gx times, and now the product rule applied to the second part, the derivative of g times the ln of fx plus gx times the derivative of the ln of fx, which is of course 1 divided by fx times the derivative of fx. So f to the power g prime is equal to f to the power g times g prime ln f plus g times f prime divided by f. You should not memorize this method, but you should just memorize this method and certainly not the formula. That's too complicated. So what do? Write fx to the power gx as e to the power gx ln of fx. Just take the derivative, that's the e to the power gx ln of fx times the derivative of the exponent. And now rewrite this, if you want, using that e to the power gx ln of fx equals fx to the power gx. Let's just do this with an example. Take the function fx equal sine of x to the power x squared. Then sine of x to the power x squared equals e to the power ln of sine of x squared to the power x squared, which is e to the power x squared times ln of the sine of x. And now we can compute the derivative of f. It's the derivative of e to the power x squared ln sine of x, and that's e to the power x squared ln sine of x times the derivative of x squared ln sine of x. And that's then equal to e to the power x squared ln sine of x times 2x times the ln of the sine of x plus x squared times the derivative of ln sine of x, that's 1 over sine of x times cosine of x. So we can rewrite this and simplify it to sine of x squared to the power x squared times 2x times ln of sine of x plus x squared divided by the tangent of x.